Hello everyone, and welcome to the Big O for Python Data Structures lecture. This is going to just be a very brief lecture, and we're going to go over the Big O of built-in data structures in Python. And it's going to be two data structures, lists and dictionaries. So if you're already familiar with a little bit of CS background, what lists are in Python is they act as a dynamic array, and they support a number of common operations through methods called on them. And the most common operations that are performed on a list are indexing and assigning to an index position. Now what's really amazing here is these operations are both designed to be run in constant time, O1. So let's imagine you wanted to test different methods for constructing a list that looked something like this, 0, 1, 2, all the way to 10,000. What we're going to do here is go ahead and compare various methods on a list or through a function, such as appending to the end of a list, concatenating a list, or using tools such as casting and list comprehension. Alright, so instead of jumping over to the live code, I'm just going to go ahead and show you the methods I built out here. So zooming in, first method is this function method 1. We take an empty list and then say for n in x range, or range if you're using Python 3, in 10,000. Go ahead and take your current list and then add n to it, which is already in a list. Method 2, what it does is, it takes L, puts it as an empty list, and then it uses the append method. Method 3 uses list comprehension, again using xrange the generator, in order to create that list. Method 4, takes the range and just uses a straight range function. In Python 3, you'll have to use this, list range 10,000. Okay, so if we test these methods using the timeItMagic function, you'll see here that clearly the most effective method is using the built-in range function in Python, which is good to know that the built-in method is the most efficient one. And in most cases, that will be true. The people that write and created this language take a lot of time to think about these things, and that's why built-in functions are very efficient and usually the best choice instead of building out your own functions. So it's important to keep these sort of factors in mind, such as using range or built-in functions, when you're writing efficient code, when you're perhaps whiteboarding on an interview question. So more importantly, we want to begin thinking about how we're able to index with a constant time. We're going to discuss this in more detail when we cover arrays in general, but for now, what I want you to do is just be aware of this table right here. It's a table of Big O for common list operations. So here are all the list operations or different methods you can perform on a list, and here's their Big O efficiency. And remember, this is just time complexity. Okay, so keep that in mind. We'll discuss how this actually works later on in the course when we discuss arrays. Dictionaries in Python, again if you have a CS background, are an implementation of a hash table, and they operate with keys and values, so you're familiar with this already. K1, 1, K2, 2, and then you can call that K1 and it'll bring out that value. So again, something that's pretty amazing here is that getting and setting items in a dictionary are also in constant time. So hash tables are designed with efficiency in mind, and we're going to explore them in much more detail later on in this course, since they're one of the most important data structures to understand. In the meantime, here's a table with the Big O efficiencies of the most common dictionary operations. All right, so as I mentioned, this is just going to be a brief overview, and by the end of this section, and this section in general of Big O analysis, what you'd have developed is an understanding of how Big O is used in algorithm analysis, and you should be able to work out the Big O of an algorithm you've developed. Okay. So get ready, there's a quiz up next to test your understanding, and the quiz is just going to consist of various code examples, and it's a multiple choice to choose the correct Big O of the performance of that algorithm. Okay, so just a quick overview. Keep in mind dictionaries and lists, which are essentially hash tables and dynamic arrays, how they work, and just start wondering how they're able to do this so efficiently in constant time. We're going to go over how arrays and hash tables are actually able to do this when we construct them ourselves, but I just want you to be aware of that. All right, So with that being said, best of luck on the quiz, and I'll see you at the next lecture. Thank you.